So today we have a spicy geometry question. The question data is very clear. There's a normal quadrilateral, nothing is specified about this quadrilateral. The diagonals are joined in such a way that the angles are formed as 20 degree, 20 degree, 40 degree, 10 degree, and one of the angle is x, and that's what we have to find. So let us say a solution which is not very usual according to the geometrical method. I am going to use trigonometry. Yes. So first of all, let us have some data from this. So in this triangle from here to here, in this triangle I can observe one of the angle is 40 degree, the other is 20 degree plus 20 degree, and that's 40 degree. So in a triangle the basis angle are same, so the sides get equal. So this side is equals to this side, and let us name that as A and A. Yes, it will be helpful later. Now let me consider another triangle for further use. Yes, so now what we will do is go with this triangle that's from here to here. Let it be clear. Yes, from here to here, and according to this diagonal, and from here to here in this triangle, and let this side be over equals to B. Yes, two of its side is A and B, and the angles are 20 degree and 10 degree. So let me redraw the triangle over here, so it's a clear version of that. Yes, so over here it's A, over there it's B, here it's 20 degree, and over there is 10 degree. Now what we are going to use is the sine rule in any triangle. The sine rule you can see on the screen. It says that in a triangle, sine of that particular angle upon the opposite side, and the ratios are equal like that way, that sine of A upon A is equals to sine of B upon B is equals to sine of C upon C, angle and its opposite side. So according to that, if I will take sine of 20 degree in this, I am using the sine rule. So sine of 20 degree upon its opposite side, so its opposite is B, and that is equals to sine of 10 degree, the other angle, and that is equals to its opposite, that is A. Sine of 10 upon A is equals to sine of 20 upon B. So from here let me obtain the value of B in terms of A, no problem. Yes, so A into sine of 20 degree and divided by sine of 10 degree, and that's the value of B. So B we have found in this. Now how can it be helpful? Let us see that. So first of all, just removing this line from here, and now look over here. Only in this triangle, that's from here to here, in this triangle the angle is 20 degree, 40 degree, and let me erase this A from here. Remember it's A over there. Yes, so these two angles are 20 and 40. So according to the exterior angle property over here, this angle becomes 20 plus 40, that's 60 degree. Yes, and now from the angle sum property in this triangle from here to here, in this triangle this angle is 60 degree, that's over there X. So according to the angle sum property in any of the triangle over here, this angle, that's the base angle. So let it be clear, I'm just erasing all the extra lines. Yes, so what we have done is reach this angle, and that's nothing but 180 minus 60 plus x according to the angle sum property, and we will keep it as it is only, that's 180 minus 60 plus x. You will get to know why it is like this way. Yes, now the final time we are going to again use the sine rule. Yes, and now in this biggest triangle, that's from here to here, from there, and this line. Yes, so let me redraw the triangle over here. So yes, now the angles over there. Yes, so over here the angle is mine 180 minus 60 plus x. Over top this angle is x, and it's x plus 10, so I will write 10 plus x. Yes, this whole triangle is 10 plus x, and this side is nothing but A. Remember that A and A were equal, so this side over here it's A, and the top side is already equals to B. So again you can guess the sine rule will be used like sine of 180 minus 60 plus x, this is one of the angle, and its opposite side is B, upon B is equals to sine of 10 plus x. So let me write that sine of 10 plus x, that is one of the angle, and upon the opposite side, that is nothing but A. So sine of 10 plus x upon A. Now remember that we have the value of B, that's in terms of A. That's why I have kept it in terms of A, because as I will put the value of B over there, so it will have a in the denominator, and A is also in the denominator on the other side, so they both are going to be cancelled. And this as 180 minus 60 plus x, because as they are the sine, means there's a sine 180 minus theta, and that's equals to sine theta. So sine of 180 minus 60 plus x will be nothing but sine of 60 plus x, and upon the value of B, and the value of B is nothing but A times sine of 20 into sine of 10. And there's also a little twist over here. What we will do is, like, according to the trigonometry, that sine of 20 degree is nothing but 2 times sine of 10 degree into cos of 10 degree. It's the identity that sine of 2 times alpha is 2 times sine alpha cos alpha. So because of that, it becomes this n upon sine of 10 degree. So sine of 10 degree and sine of 10 degree got cancelled out. So we get that b is a into 2 times cos of 10 degree. Yes, this is much better version. So instead of b, I will write that value, that is a into 2 times sine of cos of 10 degree, and that's nothing but 2 times a times cos of 10 degree. Yes, that's the value of b, and that is equals to sine of, yes, let it be clear, yes, it would be sine of 10 plus x and upon a. Now we can see that a and a got cancelled out, this gone over there, so it will form like this way. Sine of 60 plus x is equals to 2 times cos of 10 degree and into sine of 10 plus x. Now according to the trigonometry identity, as sine of a plus b, so let me write that over here because we are going to use that. Yes, so it says that sine of a plus b, sine of two angles are added together, sine of a plus b is sine of a cos of b plus cos of a and sine of b. So using this identity, we will open sine of 60 plus x and sine of 10 plus x. So it will be helpful, yes. So let us do that over here quickly. So sine of 60 plus x will be sine of 60 into cos of x plus cos of 60 into sine of x, that is equals to 2 times cos of 10, as it is outside, and inside the bracket it would be sine of 10 plus x, that's sine of 10 cos of x plus cos of 10 and sine of x. Now just opening the bracket over here, so it would form 2 times sine of, that's cos 10, yes, so 2 times cos of 10 into sine of 10 into cos of x. Now remember the identity, 2 times sine a cos a is sine of 2 times a. So because of that, here 2 times cos 10 sine 10 will become sine of 20, and the cos x as it is, so sine of 20 degree into cos x, and plus here it will form 2 times cos 10 into cos 10 becomes 2 times cos square 10. And remember the identity that cos of 2 times alpha is 2 times cos square alpha minus 1. So from here we get that 2 times cos square alpha is cos of 2 times alpha plus 1, and if I will put alpha is equals to 20 degree, not 20, if I will put 10 degrees, so I will obtain 2 times cos square 10 is equals to cos of 20 plus 1. So let me write over there that here it will be cos of 20 degree plus 1 and into this sine x, so into sine x. I've just opened the bracket, and when this multiplied with sine 10, it formed sine of 20 degree, and when this multiplied with cos 10, according to the identity, it formed cos of 20 degree plus 1, and that is equals to this all things, that is sine 60 into cos x plus cos 60 into sine x. Now what we will do is that you can observe it has a angle that's sine x, and over here it has an angle that's sine x. Here it is cos x and here it is cos x. So I will just put the cos x together and the sine x together. So it would be like sine x, it has an angle that's 60 degree, not 60 degree, cos of 60 degree, yes, cos of 60 degree. When this come over there as a minus, so minus of cos of 20 plus 1, and I have just taken the sine x directly common, and that is equals to cos x and into sine of 20 minus sine of 60, yes, minus, because sine of 60 into cos x gone over there, so it becomes negative, and from both these terms, that is this term, and when this shifted over there, I have just taken the cos x common out, and similarly when cos 60 sin x was there and this was there, so when this shifted over here, it becomes negative, and after that I have directly taken the sin x common. So now let us have the simplification over there. So sin x as it is inside the bracket, cos 60 has a perfect value, that is 1 by 2. So 1 by 2 minus cos of 20 plus 1. So not plus 1, it would be minus 1 because it's negative outside the bracket. Now 1 by 2 minus 1 is, it is negative 1 by 2, yes. So negative 1 by 2 and negative cos of 20 degree. So taking the negative common, so it would form like 1 upon 2 plus cos of 20 degree, and the negative is angle, means it would form sine of x into that negative, and this terms, that is over here So this can be taken common out, so it would form negative sign over there. It's not the angle, but it has a multiple over there. And 1 by 2 is nothing but cos of 60 degree. So I will just put that over here. So cos of 60 degree plus cos of 20 degree. Yes, now let's move to the other part. We can do a thing that this negative just shifted over there, so the sign gets changed over there. So cos x, now it becomes sine of, not sine of, it's, yes, sine of 60 minus sine of 20. Because of the negative we have got over here, I have just shifted over here, so inside the bracket the sign gets changed. Now remember the again a normal identity. There are two identities you can just see on the screen. Yes, now because of that it would form over here, it as sin x as it is, and cos a plus cos b would form 2 times cos of a plus b. So 60 plus 20, it is 80, and 80 upon 2 is 40. So cos 40 into cos of, now the subtraction of this both, n upon 2. So cos of 60 minus 20 is 40, 40 upon 2 is 20. That is equals to cos x as it is. And now sin 60 minus sin 20 becomes 2 times sin of 20 degree and cos of 40 degree. That two identities used over here. Now 2 cos 40, 2 cos 40 get cancelled out. So sin x into cos 20 is equals to cos x into sin 20. Now this sin x can be shifted as division, and this sin 20 can be shifted as division. So cos 20 upon sin 20, so it would be formed like cos 20 upon sin 20, that is equals to cos x upon sin x. And from here it's very beautiful, it would form cot of 20 degree is equals to cot of x. Now comparing both the sides, we get that x is equals to 20 degree. We will not go as a periodic because it's in a simple quadrilateral, and it should be under, as we can see, it should be under 90 degree. So we get that x is equals to 20 degree, and that's our answer. That's very beautiful. According as we have used this sine rule, it becomes very nice and beautiful. Just applied the sine rule in two triangles, obtained. As I have told many times in geometry, just exclude the variable as much as possible. So we have excluded b as we get it in terms of a. Then again the sine rule, so all the variables get excluded and we remain with only x. And after some trigonometric applications, not application, trigonometry identities, they are solved very nicely, and we get that x is equals to 20 degree without any assumption or without any contradiction. Yes, and that was our answer, x is equals to 20 degree. At final, I am showing you the final solution at once. This is the first time we applied the sine rule in over here to exclude the variable b. Then we have applied over here, so excluded the variable a and got a single equation. It's a trigonometric equation in terms of x, and it was solved very nicely, and we get that x is equals to 20 degree. So if you have any alternate method to this, you can do comment below, or else you can DM me on my Instagram. Link is in the description. When we give our viewers a better solution to the same question, it spreads the knowledge.